In this problem, we're applying the compound interest formula to determine the account balance after some amount of years. So an investment of $54,000 is placed in a savings account with an interest rate of 4.13%. If the interest is compounded monthly, what is the account balance after 5 years? So our goal is to determine the account balance, A. So we use the compound interest formula, A equals P times 1 plus R over N to the NT. So the principal, P, is the initial amount in the account before any interest is applied. So $54,000. The interest rate R is 4.13%. Now here's the initial setup. Percentages behave like units. So if I'm going to divide my percentage by some number, if I'm going to add 1 to it and so on, well, it has to be expressed equivalently as a decimal. So you always take your interest rate, which is expressed as a percentage, you divide it by 100 and express it as a decimal, 0.0413. Good. Next, we see that the interest is charged or compounded monthly. So how many times does our account experience that interest? 12 times in a year. In how many years? 5 years. Now we substitute these values into the equation. So P is 54,000 times 1 plus R, 0.0413, divided by N, the number of times in a year that you're charged interest. And you could kind of, yeah, you can see that as the units for N. Let me write times per year. So N is 12, and then T is 5. Next, I love to show my work. Sometimes I calculate the quantity in parentheses, but for such a huge calculation, it's really sensitive to rounding. So I actually suggest typing it into the calculator in one shot. Just be cautious. I know it's tempting to work from left to right, but you have to remember order of operations. Parentheses first, then exponents, then multiplication. So I know you can't see what I'm doing, but I'm going to do 0.0413 divided by 12 in the calculator. Add 1 to that result. Raise your answer to the 60th power. That's your 12 times 5. Multiply your result by 54,000. So the amount in the account after interest has been applied will be $66,362.33. And that concludes how to apply the compound interest formula.